They haven't. That's the point. All right, 5-2. So remember, we're trying to go through here, and we're thinning it out down to what we absolutely must know in order to be able to do 5-5. It's 5-5s on the final. Okay, so before we dive into the new stuff, I did write right here calculator. Why do you think I wrote that? Because your calculator will really help you on this section, okay? Especially like for the graphing, we are going to breeze through the graphing because the calculator will, like, at no point am I going to say to you, you cannot use your graphing calculator. So because I'm not going to say that, then I'm going to show you exactly how to use it so that you actually can finish the questions faster instead of trying to show you the manual labor behind graphing it without a calculator. Does that make sense? If you're allowed a calculator, then I'm going to encourage it and I'm going to let you use it, and I'm not going to bother showing you the manual labor should I had said you can't use a calculator. We can use a calculator. Now, I would rather you not use a calculator here for a second because I wanted to see what do you remember with properties of exponents. Yes, I know you could have easily typed those in your calculator and gotten the answers. That wasn't the point. The point was, what do you recall? So here we go. Let's see what you remember. 2 cubed means 2 times 2 times 2, which is 8. 9 squared, 81. So far, so good. Now, let's refresh you on rational exponents. If you recall, I'll actually skip to this one. Go to the 9 raised to the 1/2 power. I'm going to rewrite it because I don't like when my fractions are written out linear like that because it's hard for me to remember it's a fraction. That's just me. I'm going to write it like this. Makes me think of Hogwarts. 9 3/4. Do y'all remember when we were rewriting rational exponents and I said start with the bottom, and I said the bottom of the fraction will be the root. Okay, close. So this means you are taking the square root of 9 to the 1st power. And the way you rewrite it is when there is a fraction in the exponent, it means it's a radical. So the base is under a radical. And the way you figure out the 1/2 part, if y'all recall me saying, where do roots grow? Roots grow in the ground. The root of the fraction, the bottom of the fraction, is the root. And then the top of the fraction is the exponent. Okay? Now, obviously, I need to clean that up because no one writes the 2 on a square root. It's understood. So that's actually just the square root of 9 to the 1st power, which is just 3, right? Now, that one refreshed you, I hope. Come over here to this one, 64 raised to the 1/3. So I'm gonna rewrite it like this, and I'm actually going to change colors and point. This is going to be your exponent. This is going to be your root. So it's going to be the cube root of 64 to the 1st power. I don't need to write the 1, right? All good? And then what is the cube root of 64? Now, how do you type that in your calculator? 2 ways. Hit the math button. If you hit the math button, you're going to notice there's one option, which is the actual cube root. It'll say it's a little 3 with a root. There's another option that looks like a blurred out root. And that's where you're allowed to enter whatever root you want. Let me show you the difference between the two. Number 4 is the cube root. Number 5 is any root that you need to take that's not a cube or a square. If you ever have to use number 5, you have to type the root that you're actually doing first before you type the root. So like if I wanted the root of something, I have to type the 5, then I have to go to math and hit that I want that root, and notice it bumps it up. Okay? But we're not doing that, we're doing cube root. So cube root of 64 is 4. All right, you do the next 2. Yeah, because there's no partial credit. Yeah. When you finish the next 2, look up here and see if you got the same thing. I just typed that in my calculator and it gives me 32. So if you're wondering how I got that, I typed it in the calculator. How does the calculator get it? It's going to evaluate 8 to the 5th, and then it's going to take the cube root of whatever that is, which is 32. Get that? Okay, let's refresh you on negative exponents. The negative exponent doesn't actually hold a value to it. It means you need to take the base and the power and you move it to the opposite position of an understood fraction. So like right here, 5 is the negative 1 power. This means move. It means move it. And you might say, where are you moving it to? Well, it's understood to be over 1, which means it's in the numerator's position, so you're going to move it to the denominator's position. When you move it, you drop the negative. So this 5 to the first power is going to go to the bottom of the fraction, which when I do that, there's nothing left on top. What's understood to be on top, y'all? 1. And then now I'm just going to write that that's 1/5. So you do the next one. All right, look and see if you got the same thing. Well, I went ahead and cubed 7. Just because it bothered me. If you left it as 1/7 to the 3rd power, then you have it right. Is that what you had? Oh, what you had? That's the decimal of it, yeah. Leave it as a fraction. The last 2 is just to remind you that anything to the 0 power is, let's try it again. Anything to the 0 power is 1. Here's how you remember this. I know you can type it in your calculator, but here's how you remember it, because it is easy to think, oh, it's 0, but it's not. Here's how I tell myself this. I say to myself, I'm going to write 36 0 times. Because doesn't this up here mean I write 3 times? Doesn't that translate to that in expanded form? So I always tell myself, so I don't have to rely on my calculator here, write 36 0 times. Okay, that means don't write it at all. Which means there's an understood 1. So that's how I remember that. So even if it's 500, doesn't matter. 1. Okay? Alright. Before we can attack logs, we have to understand that logs are the inverse of exponential functions. And we're going to graph a couple. You're going to love the graphing part because we're going to rely heavily on that table feature in your calculator, and we're just going to sketch. Okay? Look at this one. Let's make a note to ourselves. This means it's exponential because the x is in the exponent's place, right? We are simply going to go to our calculator. We're going to enter in y equals. And then to be able to actually graph it, we need to know the actual numbers. We're going to go to table. I would probably check your table set. So we'll do second table set. How is it written? It's just TBL. TBL set. Check your table set. Make sure that it's not something crazy. And we do want everything to be on auto. Remember that shortcut we did, that one problem, and we changed it to ask? We need to go back to auto now, because then it's just going to generate the list. So then you would do second table. All right, let's do it. Y equals, it's 2 to the x power. Now I'm going to go to my table set, make sure it's on auto. Second table set, see mine's still an ask. We'll change it to auto. Bless you. Now I'm going to do second table. There's your T chart. We don't want to stick just to the, like, if I went and I graphed that, then that's just going to be over here, right? I need to know what's on the left. So I'm going to scroll to kind of get an idea of where it is. Okay, so it starts out at 0. If you plug 0 in, you get 1. So I'm going to plot 0, 1. You plug 1 in, you get 2. Plug 2 in, you get 4. 3 gives you 8. 4 gives you 16. 5 shoots off the graph, right? Now you can get an idea of where the curve is. Now let's look at the ugly numbers. If you plug -1 in, you get a half. So -1 and then a half. If you plug -2 in, you get a quarter. What's it doing? As I go with my negatives, what's it doing? It's getting smaller. If I was to keep scrolling and scrolling and scrolling and scrolling, is it ever going to, is a y value ever going to become negative here? No. It's an asymptote. Remember that? So you can see, I just messed my calculator. You can see that it's approaching 0. And at this point, once you know where it's approaching, you can just say to yourself, okay, so here's my curve. It's coming down, it's coming down, and it's approaching 0. There it is. Alright, let's do the next one. We're entering 1/2 raised to the x power. Okay, I need you to make a note. Be careful. If you're entering a fraction raised to an x power, be careful. I'm going to make a note. In the calculator, it's not, meaning don't type this, don't type 1 divide 2 caret x. Because if you type that, then that would actually, and I'm going to change to red here, that would actually be the function y equals 1 over 2x. Is that the equation that they told me to graph? No. So you have to remember parentheses, okay? So I'm going to change to green. I'm going to say use parentheses around the fraction. Because if you do that, then you'll enter it correctly. So in the calculator, you would say parentheses 1 divide 2 close parentheses caret x. See the difference between the two. Alright, so I'm going to type that in. We're going to go to table set, and we're going to graph it. Okay, so parentheses 1 divide 2 close parentheses caret x. And my table's already fixed, so I'm just going to go to table. Second table. So this one is, you can graph negative 3, 8, you can graph negative 2, 4, negative 1, 2, 0, 1. This one is like a flip. Now it's going this way, right? Now you can see negative 4 goes to 16, negative 3 goes to 8, what was it? Negative 2 goes to 4, negative 1 goes to 2. It's going this way now. Alright, we did those two because to show you the difference between an exponential growth and an exponential, starts with a D, decay. We just did one of each. Go to the next slide. They are copied there. Well, not the exact ones, but there's examples of each. You will notice that exponential growth, remember you always read graphs from left to right. That's how you know which direction it's actually running. How do you know which one is a growth and which one's a decay without graphing it? Look at these examples. These are just 3 different examples. Look at the difference between them. Growth, running up. What do you notice about the base? It's greater than 1. Decay, coming down. Notice the base, less than 1. So, check the base to determine growth or decay. All right, let's label this. This is exponential growth. Oh my. Because the base, and I'm going to do B, or I'm just going to write the word base. The base is greater than 1. This is exponential decay because the base is less than 1. And I'm going to make a small note here that says don't focus on decimals. And what I mean by that is some people might look at this and say, hey, that's a decay. And I'll say, why? And they'll be like, because decimal. Yeah, but it's greater than 1, right? So just because it's a decimal doesn't mean it's a decay. It's all about whether it's greater than 1 or less than 1. Bless you. All right, go to the next slide. Here are 3 exponential functions. It says, graph each of the following by hand. We're going to use our calculator. Before doing so, describe how it can be obtained from the mother function. This is the mother function right here. Now, you might be wondering why the mother function is a 2. Well, if it had been a 1, and x, changes, nothing happens. 1 to any power is still 1. So the activity actually comes in when it's a 2, because that's when it's going to change. Here's what you need to remember. Recall the mother function formula. With exponents, the mother function, like generic form, you're going to have some base to some power, x. If there is a right or left shift, it's going to be next to the x, so I'm going to put minus h. And do y'all remember what the asterisk means? This is an asterisk. Kind of hard to tell. It means there's a sign change there, so be careful. Anything next to x is counterintuitive. So if it said like 2 to the x plus 4, that would mean it's the mother function actually going left 4. And then now, sometimes there is something at the end where it just takes the whole graph and goes up or down, right? So let's do these 3, and we're just sketching. We're not going to worry about the T-chart. First of all, is this growth or decay? This is growth. Second of all, where is it going? It is going right to. How do you know? Because the little minus 2 here is actually next to the x. It's intuitive here. Listen. If it's next to the x, what direction does the x-axis run? Left and right. So this is telling you, hey, this is a right or left movement. Now, it's to figure out which direction you're going, it's backwards. I see minus 2, that would make me think left 2, it's actually right 2. So we're going to sketch, remember the mother function ran like that kind of, we graphed the mother function earlier. So it's just going to kind of shift over. Well, mine definitely shifted a lot. What's the next one? Is it growth or decay? This is still growth. Where is it going? It's going down 4. That number at the end is not in the exponent's place, which means this is that decay. And so this is either I'm taking the whole graph up or I'm taking the whole graph down. This is going down 4. So instead of the mother function running like right here, we're just going to come down here to the -4 and try our best to stay along it and then shoot up. Now the next one's slightly tricky because look at it. The exponent stuff is at the end. So I'm going to rearrange this. I'm going to keep the signs with it. I'm going to pull this to the front, and that's a +5. Now I can actually see what I'm working with here. So is this growth or decay? This is decay, which means when you go to sketch it, we're not shooting up. Now we're actually going down. There's a lot going on here. The easy one would be the one at the end. That would mean what? Up 5. right?
Oh, yes,
Right here.
thinking about it.
This is going to be up 5. What's the negative in the front? Since it's in the very, very front, it just means reflecting over the x-axis. So it helps to graph the mother function, like to plot it. Decay ran like right here, right? So we're going over the x-axis, which means now it's going to be like here, but then it's going to go where? Up 5. So now I'm going to take that and just go up to the 5, and I can kind of sketch it. All right, y'all can pack up and go to second. Y'all are going to come to my first lunch, right? Let's see, passes. Actually, I will just send a generic email with the whole roster that just says, if any of these students ask to come to my flex, please allow them, and I can report to your teacher that you showed up.